Welcome everybody, welcome to the Tomb of Illumination. Today's video is about the coordinate system of our flat earth. And what prompted me, what led me down this path was I was preparing a video in regards to this Howard Terence, the supposed genius. Now, you obviously don't get a platform unless you're in the club, okay? He's been on Rogan, you know, so Freemasons have put him forward as their new Einstein, and he's black, so they think that's really good. Going on about the curvature of, well, he didn't highlight that too much, but the curvature of space and how there's no straight lines in the universe, and making out that this is a new revelation. We've known about this forever, because we know we're inside a toroidal field, and the toroidal field is a curving magnetic field, isn't it? The toroidal field is the flux, the curving magnetic field. So, allow me to elaborate on more of this curve, and I'll save the other details for this specific movie. I'll do a video on that after this, okay? So, I've just been online. You know, once you start something, everything starts opening up to all sorts of things. But anyway, we got along the lines of poloidal and toroidal fields, and there's so much garbage on poloidal and toroidal fields of Earth. It's unbelievable. But I've taken some screenshots of some things I'll read, and I'll read it out now. So in this specific paper, I've only just taken some screenshots. In this paper, we have derived a necessary and sufficient condition on the scalar field. They got this symbol, squiggle, E-like, back to front E, in the standard poloidal toroidal representation. At the curl of a poloidal field, that the curl of a poloidal field should be a toroidal field. It is given by conditions 1 and 2 combined. Its geometrical meaning is that each isosurface of a, that squiggle again, must have a constant normal curvature in all directions at all points in a 3D Euclidean space. Okay? So it's a 3D Euclidean space, yet old Howard up here starts referring to, we've just stuck to the standard 2D Euclidean. So what have we got here? Is it Euclidean 2D or 3D? Bear in mind, just in case you haven't been following me, where's my ruler? Can't find it. We've got a 3D projection here from a magnetic field. It's in the magnetic field, a 3D projection. Comes from a 2D plane. Okay? So everything we see in our skies comes about from this 3D motion. And if you look down inside the vortex, the central vortex of creation where this S-curve is, you get the Fibonacci. Okay? Spiraling out like this. It's an S-curve. Right in there, coming out wider and wider. Right into here, the centre, comes out wider and wider. And then its returning cycle creates the cardanoid, okay? So there's that page. Take the next page. Euclidean space. So he's talking about Euclidean space, 3D Euclidean space, but old Howard's saying it's 2D. Only spheres and planes satisfy this condition. Thus, there can be no toroidal field surfaces for the standard poloidal toroidal representation other than spheres and planes. The poloidal toroidal conversion through a curl operation, we're going to get more into that in a minute, therefore can be done only in an approximate sense if a poloidal toroidal representation is used for describing dynamos or other magnetic processes in a whatever. That's all I took from those screenshots. Other magnetic processes in a celestial body of a highly oblate shape. So you've got to understand the Earth is an oblate spheroid. Just like that. An oblate spheroid. It's not a 360 degree nice spherical ball. Okay? So they're working on these shapes. And everything spirals out from the center in the Fibonacci. Curves around like this. So you take this as just the northern hemisphere, comes out, spirals around like this. Shoots straight down to the ground at the tropical of Cancer, goes through the ground, does its thing, and then comes up out in the south. You've probably seen this symbol before. This is over and under. It'll come over and then go under. Okay? We're getting more into that in a minute. So, however, exotic surfaces corresponding to our standard toroidal field surfaces might be available in dimensions more than 3 or in non-Euclidean spaces, e.g. in a curved 3D space-time, which is, though intriguing, far beyond the scope of this presentation. Now, some of you who've been following me might have seen my Euclidean fifth postulate, Euclid's fifth postulate, quite a while back. I took it down because I wanted to change it and redo it. Never got around to it yet. How the fifth postulate refers to the 3D dome, sphere, man's arc of horizon, how that figure can be traced all the way around the dome, but we'll get into that some other time. Some other screenshots. So there we have the, well, I've drawn it up here actually. You know, understanding the toroidal field is around this way and ploughshare this way. So going back to this model, it's coming out of the centre over this way as ploughshare, but it's always moving. So you get the toroidal. Okay? At the end of the day, it's just a torus field. But science, nobody except Lindsay Harris has ever talked about the tropical gap. How it's a split cell. Okay? This is what it's looking like. The magnetic field comes up here but shoots down here. So it's curving up and around and then straight down here to go through the ground to the other pole. But this makes up the full picture. So you've got to imagine the gap that's in here. The tropical gap that's in here. So the field's actually coming around and dropping straight down in this gap, which is Cancer here, and then coming through the ground and up and over again. Okay? So it's a continuous field. It's your infinity symbol, basically. Well, you look at it that way, as a flat 2D plane. So it says the diagram depicting the ploughshare, which represents this figure, this symbol here, direction represented by that red arrow up there, and the toroidal, which is this symbol down here. That one down there, represented by the blue arrow. So it's got the toroidal, okay. Well, they represented that as the azimuthal too. Azimuthal symbol, isn't it? Anyway, the earliest use of these terms cited by the Oxford English Dictionary is by Walter M. Althusser, 1946, in the context of the generation of the Earth's magnetic field by currents in the core, with toroidal being parallel to lines of latitude and ploughshare being in the direction of the magnetic field. So it's coming out of here, coming out, but you've got this movement, constant movement around here, i.e. towards the poles. Now, this is one thing that you never heard of before either, except through this channel, the poles. What are the poles? Well, they're not telling you this gap. This is one pole, it goes to here and drops down to here, so you could say that's the other pole. But on an overall scheme of things, this can be a pole and this could be a pole, but they are basically the same, but one's a strong force and one's a weak force. So this field here at the south is attracted to here, Capricorn, where it drops straight down to the ground, but it wants to seek equilibrium, so it's racing over to here, but it can't cross this dielectric zone. Okay? I've drawn these little domes, arcs, man's personal arcs of horizon, but then you have the earthly system from the north all the way to the south as a meridian, an arc like this. Okay? We'll get into that more too in a minute. I jumped the gun on that last one. Anyway, toroidal and ploughshare coordinates. The term toroidal and ploughshare refer to directions relative to a torus of reference. They describe a three-dimensional coordinate system in which the ploughshare direction follows a small circular ring around the surface, while the toroidal direction follows a large circular ring around the torus, encircling the centre void. We've got up here, got the same picture. A diagram depicting the ploughshare direction represents the radial. Okay, read that one. Doubled up on that one. The short way around the torus, the corresponding coordinate being denoted by the y in the slab, approximately blah 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 coordinates. The third direction, normal to the magnetic surface, is often called the radial direction. I'm going to get into that a bit more. So you might want to look up spherical coordinate system on Wikipedia. In mathematics, a spherical coordinate system is a coordinate system of three-dimensional space. Okay? So we're talking about the oblate spheroid. All comes about from this expansion, blown up image of the hyperboloid centre, where the position of a given point in space is specified by three numbers: radius, angle of slope, and the radial, or the radial distance of the radial line R connecting to a point to the fixed point of origin, which is located on a fixed polar axis, or zenith. So they're talking about the direct field out this way, or zenith, you know, that's your zenith here, and the polar angle, you've got a polar angle, and the radial line R, and the azimuthal angle. Okay, so three coordinates to take into account. So we're going to get into that. I'll get into that now. So, where's my little stick? I'll find it. What have we got here? So, Earth's coordinate system is calculated on an oblate spheroid. Research toroidal and ploughshare fields. They call it a spherical coordinate system. But at the end of the day, you will find Earth's coordinate system is based on the oblate spheroid. Just radial distance, polar angle, and azimuthal angle, okay? So think of three-dimensional space, which is within here. This is a vortex, and think of the three-dimensional space in there. All goes back up to a flat plane. You look down on the flat plane, you'll see the Fibonacci cycle, golden ratio. So you've got radial distance from the fixed point of axis being the North Pole, okay? So it's all coming out of the North Pole. They use the North Pole to start with. This is where they, in the Northern Hemisphere, they call it their spider web. It's even in celestial navigation. Fixed point of axis being the North Pole or zenith axis. This direct line coming out. Okay, coming out. The polar angle. What angle? The vertically leaning curved path of the ploughshare. This is the wave, the magnetic field wave of a toroidal field. It's the ploughshare, it's that shape. It's mentioned in the Bible. It's the fin of a shark. Even the shark in the mythological stories comes up when they're describing this, talking about this. Vertical leaning curve path. So you've got this point up here, and then you take it on the lean. It's the curve. Or Fibonacci or golden ratio. The angle of the radial line, referring to number 1 here. Same line but curved on that slant. And look, you have this in physics. What is curved linear? It's either curved or it's linear, but they know darn well. You take it and it's curved. Physics. 3. The azimuthal angle of the radial line. So you've got radius here, you've got the angle, sloping angle, and over here azimuthal. Understood commonly as being from the north. But in reality, in this situation, from the observer to a point of interest, projected on the same plane as the reference direction to the zenith. In other words, your personal arc of horizon relative to your zenith. Okay? This is when you come into Enoch, circles within a circle. This is the overall earthly position. They want to know where you are. Then from there, they give you everything around you in your arc of horizon. It's all connected to celestial navigation. So they need to know where you are, and then they'll give you the, you can go to your almanac or whatever, but they've worked it all out on a grid system using this. It's all in math. They know the curve, they know the curving field, and they created the grid, and it's all about GP points back down to the earth, the flat plane of earth within inside the toroidal field. So what do we get? 3 sun, oh, there's something else to consider while I'm here. 3 sun analemmas to consider. The overall earthly one in each hemisphere, and 3, man's personal perspective of one within his arc of horizon. It's all about man looking out from the centre of the universe. Physicists tell you that. Don't ignore it. That means you're inside the circle. Okay? Not this. Think of magnetism and what happens when you cut a magnet. It breaks down into smaller dualities or short integers. Large, break it down again, one in the southern hemisphere, one in the northern hemisphere, and then you break it down again to man's personal arc of horizon. There's a circle within a circle. You draw that circle in here if you want. And it's just like celestial navigation on a flat earth. You draw a circle around that GP point of the star you've taken a reading from. Then later on you take another reading, it'll give you another circle, keep doing it, and you'll find an axis point. A point that will pinpoint you as to exactly where you are in relation to the GP points of the stars. So this is what he's on about. No straight lines in nature. Well, we've known about this forever. I mean, even I've, as a retired builder, been talking about this since I started making videos in 2019. So if he's such a genius and there's no curved lines in nature, and he's talking about the magnetic field of Earth, somebody go and ask him, how does he explain the tropics then? because the tropics are straight lines. That's a direct straight line magnetic field from the south to the north, vice versa. And in this zone here, in the night sky, in the celestial bodies, you're seeing the rotation of the southern hemisphere and the rotation of the northern hemisphere. And right between them, at a certain time of the year, you get Orion's belt passing through in a direct straight line. Basically, straight compared to the curvature of the star trails. You see the star trails in the far north if you're in the southern hemisphere on the horizon, and you've got your big swing of stars, circular motion, but there's Orion's belt flowing through the gap, nice and straight. So we have a straight line from there to there. Nobody talks about this on your YouTube and on your science sites, do they? They're all talking about curved magnetic field lines and blah blah blah. Actually, they don't even want to delve into that too much. They want to keep it all away from you because they don't want you clicking on thinking, oh, wake up and realising they've all lied to you. Here's another image of the southern hemisphere. There's the northern hemisphere. The southern hemisphere comes in, overlays, or moves under the northern hemisphere actually, during the seasonal changes of the flex of the ecliptic plane in here. Up, down, up, down. So that's all I wanted to say. Just look up a few sites about the trying to understand the coordinate system of Earth. How it's all based on this oblate spheroid, curved linear, curved, the Fibonacci golden ratio, curved linear, S curve, looking down the S curve. This is the S curve, three-dimensional, the realm we come from, but we're all out here, all projected from this place in here, the magic place, because it doesn't really exist. It all goes back up to the flat plane. The magic, the magnetic, the magic from the magnetic field of our realm. Most flat earthers would have already come to realise all this stuff anyway. The golden ratio is the 2D flat plane view of the 3D S curvature. 3D S curvature. But anyway, I'll start work on this video here. Probably revealed half of it in this video anyway. But anyway, thanks for watching. If you like this sort of thing, put a thumbs up, subscribe, and check out my Patreon page. Cheers.